Bismillahirrahmanirrahim. Today's video I am going to explain about Poisson distribution. Here I will explain the definition of Poisson distribution, how to find out mean and variance of Poisson distribution, and also how to find out moment generating function of Poisson distribution, and also explain some applications of Poisson distribution. So let's start. Here the definition. A discrete random variable x is said to have a Poisson distribution if its probability function is f of x lambda equals to e to the power minus lambda lambda to the power x by x factorial, where x equals to 0, 1, 2 to infinity, and it will be 0 otherwise, where the value of e equals to 2.71828 and lambda is the parameter of the distribution, which is the mean number of success. Now here some application of Poisson distribution are the number of cars passing through a certain street in time t, number of suicide report in particular day, a number of 40 bullets in a packet of 100, number of printing mistake at each page of a book, number of fish caught in a day in a certain city, number of robbers caught on a given day in a city. Now when we have to apply Poisson distribution, we have to apply Poisson distribution when the number of trial is so large. So large means 10,000, 1 lakh, etc. And the number of success or the number of failure is so little, which is near about 0, which is tends to 0. Now let's get an example. If 10,000 car passing through Sereniabad bridge, and where the probability of accident is 0.002. So here the probability of success or probability of failure is so little, about near 0, and the number of trials means 10,000 car, which is so less. In such situation we have to apply Poisson distribution. Now I am going to explain how to find out mean and variance of Poisson distribution. Here the mean equals to expectation of x. Here the mean, which is expectation of x, can be written as summation of x into f of x. We have known the summation will start x equals to 0 to infinity. Now the next line will become summation of x equals to 0 to infinity x into we have known f of x of Poisson distribution will be written as e to the power minus lambda to the power x by x factorial, and then now we have to explain the summation of x into e to the power minus lambda to the power x by x factorial. Then if we put x equals to 0, then the whole term will become 0, plus if we put x equals to 1, then the whole term will become 1 into e to the power minus lambda to the power 1 by 1 factorial. Here x equals to 1, and the next term will become x equals to 2, 2 into e to the power minus lambda, lambda to the power 2 by 2 factorial plus some other function like this. Now here we can write as e to the power minus lambda, lambda e to the power minus lambda into lambda plus here 2 factorial into 2 will be cancelled out, and finally we can write as e to the power minus lambda, lambda square plus dot. Here we can common, here we take common lambda into e to the power minus lambda, we take common lambda into e to the power minus lambda, then the remaining term will on plus here we can write lambda by 1 factorial plus lambda square by 2 factorial plus dot equals to lambda into e to the power minus lambda. We have known the whole term will take the value e to the power, will take the value e to the power lambda. The whole term will take the value e to the power lambda, and here e to the power lambda and e to the power minus lambda and e to the power lambda will be cancelled out, and the remaining term takes the value lambda. This is the mean of Poisson distribution. This is the mean of Poisson distribution. So now I will explain about how to find the variance of Poisson distribution. How to find about the variance of Poisson distribution. We have known variance formula equals to e to the power x square minus e to the power expectation of x square minus expectation of x whole square. We have known e to the power x, which is expectation of x, which is mean, so we have to find out the value expectation of x square. Now firstly we have to find out expectation of x square. So expectation of x square can be written as summation of x equals to 0 to infinity x square into f of x, and then summation of x equals to 0 to infinity. Here the term x square will be written as x plus x into x minus 1 into here the term f of x, here the term in f of x value into p of f of x, and now the summation will start x equals to 0 to infinity, x equals to 0 to infinity x plus x into x minus 1, and here the function of x will be written as e to the power minus lambda, lambda to the power x by x factorial. Now Now this line we can retain as summation of x equals to 0 to infinity, x equals to 0 to infinity, x into e to the power minus lambda to the power x by x factorial plus summation of x into x minus 1 e to the power minus lambda to the power uh, lambda to the power x by x factorial. Now explain the summation. Hold the term. Now explain the summation. This term can be written, this term which is we find out from mean. We find out from mean summation of x into e to the power minus lambda to the power x by x factorial, which takes value lambda. Now we put here the whole term will become the value takes value lambda plus this remaining term, lambda plus this remaining term, x equals to 0 to infinity, x into x minus 1 e to the power minus lambda to the power x by x factorial. Now here I explain the summation. Lambda plus this term. I explain the summation lambda plus. If we keep x equals to 0, then whole term will become 0 plus if we keep x equals to 1, then whole term 1 minus 1 equals to 0. 0 into something equals to 0. So this whole term will become 0 plus if we keep x equals to 2, then we have 2 into 2 minus 1 e to the power minus lambda to the power 2 by 2 factorial plus if we keep 3 here, the term 3 into 3 minus 1 e to the power minus lambda to the power 3 by 3 factorial plus and some remaining term like this equals to lambda plus 2 into 1. Here 2 into 1, here we can cancel out 2 factorial and 2 into 1, then this term here takes the value e to the power minus lambda into lambda square, e to the power minus lambda into lambda square plus here the term takes 3 minus 1 which is 2 into 3 which is 6 and here the 3 factorial, means 3 गुण 2 into 1 equals to 6. Here this 3 factorial and this whole term will be cancelled out and the remaining term here e to the power minus lambda to the power 3 plus so on like this. Now this term takes the value lambda plus here we can common e to the power minus lambda into lambda, we can common e to the power minus lambda into lambda square and here 1 plus we can write lambda by 1 factorial plus lambda square by 2 factorial plus lambda cube by 3 factorial plus so on like this. Finally lambda plus e to the power minus lambda into lambda square, this whole term will become e to the power lambda, this whole term is e to the power lambda and finally we can write this term as lambda plus lambda square. So the value of expectation of x square is lambda plus lambda square. Now we put this value the formula in the formula of variance. অতএব variance equals to expectation of x square minus expectation of x whole square. Expectation of x square's value lambda plus lambda square minus expectation of x, which is the mean, and this value lambda square minus lambda square will be cancelled out, and finally here the remaining value lambda, which is the variance of Poisson distribution. We can denote a point that the mean and the variance of Poisson distribution are equal, which is variance of Poisson distribution. অতএব mean and variance are equal of Poisson distribution. Now I am going to explain how to find out moment generating function of Poisson distribution. Moment generating function of Poisson distribution, we can write mxt equals to expectation of mxt can be written as expectation of e to the power tx. Expectation of e to the power tx takes the value x equals to 0 to infinity e to the power of tx into here we can keep function of x, where function of x can be written as e to the power minus lambda into lambda to the power x by x factorial, and then e to the power of minus lambda. Here e to the power of minus lambda takes outside the summation. Then we have summation of x equals to 0 to infinity, and here the term lambda into e to the power of x by x factorial. Here this term the constant the constant e to the power of minus lambda will be outside of summation, and here the remaining part lambda to the power x and e to the power tx can be written as lambda to the power e to the power tx by x factorial. E to the power of minus lambda, here explain the summation on lambda into e to the power t to the power x by x factorial. Then we get if we keep x equals to if we keep x equals to 0, then the whole term will become 1, plus if we keep x equals to 1, then the whole term become lambda e to the power t by 1 factorial, plus if we keep x equals to 2 here, then the whole term will become lambda e to the power t square by 2 factorial plus so on like this. Here e to the power of minus lambda, the whole term will be written as e to the power of lambda e to the power of t. The whole term will be written as e to the power of lambda e to the power of t. And finally this term can be written as, we can write e to the power of lambda into t minus 1, which is the M.G.F or moment generating function f of Poisson distribution is e to the power of lambda into t minus 1. So if you benefited from this video, you can subscribe Arif's math class channel. Thank you.